Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on finding the equation of a tangent to a circle. If you need any extra help on this topic, if you go to Corbettmaths and go to the videos and worksheet section and scroll to video number 372, there's a dedicated video tutorial there on finding the equation of a tangent to a circle. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one, it says the diagram shows the circle x squared plus y squared equals 8 with a tangent at the point 2, 2. So as you can see, we've got this circle. This is the circle x squared plus y squared equals 8. The center of the circle is the origin here. And then we've got this tangent drawn to the circle. It touches the circle once and carries on. And it's the tangent at the point P, which is the point with coordinates 2, 2. And part A says, find the gradient of the line OP. So OP is the radius of the circle, because that's the center of the circle, and P is a point on the circle, so that's the radius of the circle. So we want to find the gradient of that line OP. So to do that, we could use a few different approaches. One approach is to make a little right angle triangle like so, and consider the rise and the run, because the gradient m is equal to the rise divided by the run. If you do the rise divided by the run, you can find the gradient of a line. So in terms of the rise is how much it rises by. So this is the origin, so that's the point with coordinates 0, 0. And P is the point with coordinates 2, 2. So to get to P from O, we would go 2 to the right and 2 up. So that means the run is 2 and the rise is 2. So that means the gradient would be the rise, which is 2, divided by the run, which is 2, and 2 divided by 2 is equal to 1. So the gradient of the line OP is equal to 1, and that's it. So that's one approach that we could use, just use the formula rise over run and work out the gradient of the line that way. Some people do like to use this formula where they do m is equal to y2 minus y1 divided by x2 minus x1. Where x1, y1 are the coordinates of one of the points and x2, y2 is the coordinates of one of the other points on the line. So here, if we look at this first point, 0, 0, the origin, we could say x1, y1. And then here we've got the next point P, we'll call that x2, y2. And then if we substitute them into the formula, we get the gradient m is equal to y2, which is 2, subtract y1, which is 0, divided by x2, which is 2, subtract x1, which is 0. And then 2 take away 0, look at the numerator here, 2 take away 0 is 2. Now let's look at the denominator, 2 take away 0, which is 2, and 2 divided by 2 is equal to 1. So that means the gradient of that line OP would be 1, and that's it. So you could use either approach. I tend to use rise divided by run, it's just the approach I typically use, but if you wanted to use this formula, you're more than welcome to, as long as you get it right, and that's it. So for the rest of this video, I'm going to use rise divided by run, but I just wanted to mention that as well. Okay, and then part B. Part B says find the gradient of the tangent. So we know the gradient of this line. The gradient of this line OP is equal to 1. M is equal to 1 for the gradient of that line. Okay, so that's the gradient of the radius. And now here we've got a tangent. And if we think back to circle theorems, when a radius and a tangent meet, they meet at 90 degrees. That means that these two lines are perpendicular to each other. The radius will be perpendicular to the tangent. And also thinking back to the gradient of perpendicular lines, so hopefully you've studied perpendicular lines. Whenever you've got lines that are perpendicular to each other, you'll find that the two gradients will multiply together to be -1. Or another way to consider it is, if you know the gradient of one of the lines, if you work out the negative reciprocal of that, you can find the gradient of the other line. So that's what we're going to do. To find the gradient of this tangent, what we're going to do is we're going to do the negative reciprocal of 1. So in terms of the reciprocal of 1, the reciprocal of 1 is 1. Now we need to make it the negative reciprocal. What that means is to change the sign. So it was positive, we're now going to make it negative. So it means the gradient of the tangent will be -1. So it means the gradient of this line here will be m is equal to -1. And let's just check it. If we multiply the two gradients together, 1 multiplied by -1 is equal to -1. And if two lines are perpendicular to each other, the gradients will multiply together to be -1. And that's it. Okay, so we found the gradient of the tangent. That's fantastic. Okay, then part C. Part C says find the equation of the tangent. So we want to find the equation of this tangent now. Okay, so we want to find the equation of that tangent. Okay, so if I wanted to find the equation of this tangent, it's a straight line, and a straight line is in the form y equals mx plus c. The equation of a straight line is in the form y equals mx plus c. Now for this tangent, we know the gradient is -1. So it means it's y equals, now I'm not going to write -1x, I'm just going to write minus x plus c. Because instead of writing -1x, we can just write minus x, and then we've got our plus c. Okay, so we know that this line is in the form y equals minus x plus c. We now need to find c, the y-intercept. There's a few different approaches that we could use here. One approach is we know the gradient's a -1, so that means that here, this is the point 2, 2. If we go back 1, up 1, back 1, up 1, we'll get to this point here, which is B4. So that's one way I've just done it, is to use a bit of common sense. That's not how I would normally do it though, but it's just this was quite a nice question to do that. Okay, so what I would do is I would find a point that's on that line, on the tangent, and the point that's on the tangent that we know is the point P, which is the point 2, 2. So here we've got an x-coordinate of 2 and a y-coordinate of 2. And if we substitute them into here, we can find out what C is, and then we'll know the equation of the line. Okay, so y, well that's 2, is equal to -x, so that's going to be -2, and then we've got plus C. Now we want to find out what C is, so let's add 2 to both sides to get rid of this -2, so let's add 2 and add 2. On the left hand side, 2 plus 2 is 4, and on the right hand side we had -2 plus C, we're adding 2 to get rid of the -2, so we'll just be left with C. So C is equal to 4. So that means that C is equal to 4, and we've worked that out. So that's fantastic. We now substitute this back into here. We can find the equation of this line is equal to y equals -x plus, and then instead of C, it'd be plus 4. And that's it. That's the equation of that line. Y equals -x plus 4. And that's it. Okay, so that's how I would do that question. I would write y equals mx plus c, put in the gradient that we know, then to substitute in the x-coordinate and the y-coordinate from a point that we know on the line to find out c, and then we can find the equation of the line, which in this case is y equals -x plus 4. Okay, now there is another way to find the equation of that tangent, and if we think back to part A, there was a formula to find the gradient of the line, which was y2 minus y1 over x2 minus x1. So if you've got 2 points and you want to find the gradient of the line joining them, you can use this formula. There's also a formula to find the equation of a line that if you know the gradient and a point on the line, and that is that y minus y1 is equal to m bracket x minus x1, where the point x1, y1 is a point that's on the line. So in this case, the point x1, y1 would be 2, 2, because that's the point on the line we want to find the equation of. So we would call that x1, we would call that y1. And then m is the gradient of the line, which is -1, and we can substitute those in. So we'd have y minus y1, which is 2, is equal to m, which is -1, then in brackets x, and then minus x1, which would be -2, close brackets. And then we could expand the brackets here to get that y minus 2 is equal to -1 times x, which is minus x, and then -1 times -2, which would be plus 2. And then we want to make y the subject, so we would add 2 to both sides, so we'd then get y is equal to minus x, and then 2 plus 2 is equal to 4, so plus 4. And that's another way you can find the equation of a line, that if you know a point that's on the line, and you know the gradient of the line, you can use the formula y minus y1 equals m bracket x minus x1. And some teachers and some students like to use that formula. I typically just use y equals mx plus c and put in the gradient, put in a point that we know, and then find out the value for c. So that's it. So part A, we were asked to find the gradient of OP, the radius, that was 1. In part B, we were asked to find the gradient of the tangent, that's the negative reciprocal of that, which would be -1. And then in part C, we were asked to find the equation of the tangent, which would be y equals -x plus 4, and that's it. Okay, let's look at our next question, question number 2. Okay, question number 2. Question number 2, we've got this circle, and we've got O as the centre of the circle, so the origin is the centre of the circle. P is a point on the circle, which is the point 2, 6, and there's a tangent to the circle at that point P, so there's a tangent. And part A, again, we've been asked to find the gradient of OP, so the gradient of the radius. Part B, we've been asked to find the gradient of the tangent, so that'll be the perpendicular line to the radius. And then part C, again, we've been asked to find the equation of the tangent. So we're following through those steps again, so finding the gradient of the radius, then finding the gradient of the tangent, and then finding the equation of the tangent. So let's do that. So let's start off with part A, the gradient of OP. So we want to find the gradient of this radius. So what I'm going to do is I'm going to use the gradient m is equal to the rise divided by the run. So I'm going to make a little right angle triangle, just coming down there and across, and a little right angle there and across. So that's a right angle triangle. In terms of the run and the rise, well, the run, well, we'll be going 2 across there, so 2, and the rise will be going up 6. So we've got the m, the gradient, is equal to the rise, which is 6, divided by the run, which is 2. And 6 divided by 2 is 3. So that means the gradient of that line OP, the radius of the circle, is equal to 3. And that's it. So part A, the gradient is 3. Okay, part B, find the gradient of the tangent. So here we've got a tangent, here we've got a radius, they will be perpendicular to each other. So when a tangent meets a radius, they'll be meet at 90 degrees, so that'll be a right angle. So they're perpendicular to each other. And if we know the gradient of one of the lines, and we do, the radius, if we find the negative reciprocal of that, so m was equal to 3 for the radius, if we do the negative reciprocal of 3, that'll tell us the gradient of the tangent. So m for the tangent will be equal to the negative reciprocal of 3. So the reciprocal of 3 is equal to a third, because remember 3 is 3 over 1, and when you flip it over you get that's equal to a third. But also the negative reciprocal means we need to change the sign. This was a positive gradient, so we're now going to make that a negative gradient. So the gradient of this line, the tangent, will be negative 1/3. And again, we can check that if we multiply these two gradients together, we should get negative 1. And 3 lots of negative 1/3 would be negative 1. So that's it, that's right. So that means the gradient of that line is negative 1/3, and that's it. So let's write that down. The gradient of the tangent is minus 1/3. And then part C says find the equation of the tangent. So we want to find the equation of this tangent here. So the equation of the tangent is a straight line, so it's going to be in the form y equals mx plus c. We know the gradient's minus 1/3, so it's going to be minus 1/3 x plus c. And then if we want to find out what c is, what we want to do is we want to find a point that lies on the tangent. So that'll be this point here, 2, 6, and we're going to substitute in the x coordinate and the y coordinate. So the x coordinate is 2 and the y coordinate is 6. So we're going to get that 6 is equal to minus 1/3, so minus 1/3 multiplied by an x coordinate, which is 2, and then plus c. Now this is a calculator question, so you can do this on the calculator, or you can just know that minus 1/3 times 2 would be minus 2/3. If you double minus 1/3, you get minus 2/3. So 6 is equal to minus 2/3 plus c. Now we want to get the c on its own, so let's get rid of this minus 2/3. So let's add 2/3 to both sides of the equation. So on the left hand side, we're going to have 6 plus 2/3 will be 6 and 2/3. And on the right hand side of the equation, we'll just be left with c. So that means that c is equal to 6 and 2/3. So we can now substitute that into here. And that means the equation of this tangent will be y equals minus 1/3 x plus 6 and 2/3. And that's it, that's the equation of the tangent. So let's write that down. The y is equal to minus 1/3 x plus 6 and 2/3. And that's it. Now if we wanted to, we could change this mixed number into a top-heavy fraction. And to change from 6 and 2/3 into a top-heavy fraction, you could actually type it into your calculator. I think your calculator would do it for you. Or you just do 6 times 3 is 18, plus 2 is 20. So you could write y equals minus 1/3 x plus 20/3 instead. So either one of those would be totally fine, this one or this one. And that's it. Okay, let's have a look at our next question, question number 3. Okay, so question number 3, it's a similar question where we've got a circle, we've got a tangent. Part A asks us to find the gradient of the line AO, which is the gradient of the radius. Part B asks us for the gradient of the tangent, and part C asks us for the equation of the tangent. So we want to find the gradient of the radius, then the gradient of the tangent, then the equation of the tangent. So let's do that. Okay, so part A, the gradient of AO. So we want to find the gradient of AO. So to find the gradient of AO, I'm going to make a little right angle triangle. So remember the gradient m is equal to the rise divided by the run. So in terms of to get from A to O, we would go across, and we would go across 5 to get to here. So the run is 5 to get to there. And then we're going to go down 2. So the rise would be negative 2 because we're going down 2. So that means that the gradient of AO, this line here, would be the rise, which is negative 2, divided by the run, which is 5. So that means if we do negative 2 divided by 5, which would be negative 2/5. So that means the gradient of AO is negative 2/5. And that makes sense because it's going down, so it's going to have a negative gradient. And it's not really steep, so negative 2/5 would be about right for that. So that means the gradient of the line AO would be negative 2/5. And that's it. So the gradient of AO is negative 2/5. Okay, now let's look at part B. Part B says find the gradient of the tangent. So now we know the gradient of the radius. We know that the radius and the tangent will be perpendicular to each other. They meet at 90 degrees, so they're perpendicular lines. So if we know the gradient of AO, which we do, which is m equals minus 2/5, to find the gradient of the tangent, we need to do the negative reciprocal of that. So m would be equal to, well, it was already negative. When we do the negative reciprocal, that would change the sign, so it's going to be positive. That's great. And the reciprocal of 2/5 would be 5/2. So that means the gradient of this line, the tangent, will be 5/2, or 5/2, or 2.5. And that's it. So let's write that down, 5/2. And then part C. Part C says find the equation of the tangent. So we want to find the equation of this tangent. So we know the equation of the tangent is a straight line. So it's going to be in the form y equals mx plus c. m's the gradient of this line, so it's going to be 5 over 2. Y is equal to 5 over 2, or you could use 2.5 if you wanted to, x plus c. Now we want to find out what c is, so we need to find a point on that line. And a point that's on that line that we want to find the equation of is the point A, which is -5, 2. So the x-coordinate is -5 and the y-coordinate is 2. And we're going to substitute those into this equation to find out what c is. So y, that is 2, is equal to 5 over 2 multiplied by x, which is, I'm just going to put in brackets, -5, and then we've got our plus c. Okay, and that's a calculator question, so that's quite nice. So we can on our calculator do 5 over 2 multiplied by -5, and that's equal to, you get 2 is equal to -25 over 2, or that's minus 12.5 if you want to consider decimals, plus c. And then we want to get rid of this to get the c on its own, so we're going to add 25 over 2 to both sides. So if we add 25 over 2 to the left-hand side, we would get that's equal to 29 over 2, and I've just used my calculator to do that. Alternatively, you could say that's 12.5, and 2 plus 12.5 is 14.5, and that's equal to c. So that means that c is equal to 29 over 2, and we can substitute that into here, and that gives us the equation of the tangent. The equation of this tangent is y is equal to 5 over 2x plus 29 over 2. And that's it. So y is equal to 5 over 2x plus 29 over 2. If you wanted to, you can give it in decimal form and write y equals 2.5x plus 14.5, and that's fine as well. So either of those would be totally fine. Okay, and that's it. Okay, now let's have a look at our next question, question number 4. Okay, so question number 4, we've got this circle, and we've told there's a tangent to the circle at the point 2, -4. So that's the tangent to the circle at the point 2, -4. And this time we've just been asked to find the equation of the tangent. So we haven't been given part A and part B, so we've not been asked to find the gradient of the radius, and then the gradient of the tangent, and then the equation of the tangent. But this time we've just been asked to find the equation of the tangent. But we're going to need to do those steps anyway. We're going to need to find the gradient of the radius, then we're going to find the gradient of the tangent, and then we can find the equation of the tangent. So let's start off by finding the gradient of the tangent, OP. So in terms of OP, I'm going to make a little right angle triangle. To get from O to P, we would go across 2 and then down 4. So the run will be 2 and the rise will be -4. So M, the gradient of OP, this line OP, I'm just going to draw the line in there. OP, M is equal to the rise divided by the run. So the rise is -4 and the run is 2. And if we do -4 divided by 2, that's equal to -2. So that means the gradient of the radius is -2. Okay, so we've now found the gradient of the radius. Let's find the gradient of the tangent. So they're perpendicular to each other. Remember, they made it 90 degrees, so they're perpendicular. So if we want to find the gradient of the tangent, we're just going to do the negative reciprocal. So it was negative to begin with, so now it's going to be positive, and the reciprocal of 2 is a half. So that means the gradient of that line, the tangent, is a half. So that's fantastic. We've now got the gradient of the tangent. So now we can use, and just to recap that if you know the gradient of the radius was equal to -2, the negative reciprocal of that would be a half. And we can also check that -2 times a half is -1. And the two gradients for perpendicular lines will always multiply together to be -1, and that works in this case as well. Okay, so in terms of now finding the equation of the tangent, so the equation of this tangent, we're going to use that y equals mx plus c. It's a straight line, so that's the equation of a straight line. Let's find a point on the line. So a point on the line would be P. So that means the x-coordinate of that point would be 2, and the y-coordinate of that point would be -4. And we know the gradient of the tangent is a half. So let's substitute those all into this. So y, that's -4, is equal to m, which is a half, times by x, which is 2, and then we've got plus c. So let's work this out. A half of 2 is 1, so we get that -4 is equal to 1 plus c. We want to get the c on its own, so let's take away 1 from both sides. So we're going to get that c is equal to -5. So it crosses the y-axis at -5. So that means the equation of this tangent will be y equals a half x. And then we're going to replace the c with our -5. So that'll be then -5. And that's it. So that is the equation of this tangent. Y equals a half x minus 5. And that's it. So that's it. We've done that. Fantastic. Okay, let's look at our next question, question number 5. So question number 5 says, here's a circle and it's got center O, the origin, so it's the point 0, 0. And it says there's a tangent to the circle at the point 6, 8. And we've been asked to find the equation of that tangent. Okay, so to do that, what I'm going to do is I'm going to first of all find the gradient of the radius. then find the gradient of the tangent, and then the equation of the tangent. So let's start off with that radius. So here we've got the radius OP, and if we want to find the gradient of OP, we're going to do rise divided by run. So m, the gradient, is equal to the rise divided by the run. So in terms of the rise, well, to get from O to P, we will go 6 across and then 8 up. So the run will be 6 and the rise will be 8, because we're going 6 across and 8 up. So the rise is 8. We're going to divide that by the run, which is 6. And 8 divided by 6 would be 4/3. So that means the gradient of the radius is equal to 4/3. So now we want to find the gradient of the tangent, so m. So for the tangent, that's going to be the negative reciprocal. So the negative reciprocal of 4/3, well, it's positive, so let's make it negative, because remember the negative reciprocal, we change that sign. And we had 4/3, so we're going to take the reciprocal of 4/3, which would be 3/4. So that means the gradient of the tangent will be negative 3/4. So that's fantastic. We now know for the tangent, the gradient of the tangent. We also know it passes through the point 6,8. So that means now we can find the equation of that tangent. So that would be a straight line. So y equals mx plus c. Okay, now we know the gradient was equal to negative 3/4. So it's going to be y is equal to negative 3/4 x plus c. And it passes through the point 6,8. So the x coordinate will be 6 and the y coordinate will be 8. So y, that's going to be 8, is equal to negative 3/4 multiplied by x, which is 6, and then plus c. So on our calculator, we're going to do negative 3/4 times 6. That's equal to minus 4.5. So 8 is equal to minus 4.5 plus c. You may have got that's equal to minus 9/2, and minus 9/2 is minus 4.5. And now I'm just going to add 9/2 to both sides, or 4.5 to both sides. So add 4.5 and add 4.5. So on the left hand side, we're going to get 12.5. And on the right hand side, we're going to be left with c. So that means that c is equal to 12.5, or we may have it as 25/2. Okay, so now we can substitute those into here. So we're going to get the equation of the tangent will be y equals negative 3/4 x, and then plus, and then we're going to write, I'm going to write as a top every fraction as 25/2, and that's it. So that's the equation of the tangent. You may have written it in another form, you may have written it in this form, y equals minus 0.75x plus 12.5, and that's totally fine as well. So either one of those, and that's it. Okay, let's look at our next question, question number 6. Okay, so question number 6. Question number 6 is the line L is the tangent to the circle x squared plus y squared equals 68 at the point P. And the point P has got coordinates 2, 8. And we've been asked to work out the equation of the line L. Okay, so let's do that. So first of all, I'm going to do a little sketch. Now, you don't have to do a sketch here, but I'm just going to do one. So here we've got our x-axis, we've got our y-axis, we've got a circle, and then we've got a tangent at the point 2, 8. So 2, 8 will be up here somewhere. So the tangent would look something like that. Okay, so there's our little sketch. So that's just a little sketch here. We've got our x-axis, our y-axis, we've got the tangent, that's the point P there, which is the point 2, 8, and we've been asked to find the equation of that tangent. So let's do that. So let's find first of all the gradient of the radius. So the gradient of the radius, so that's the center of the circle, so that's the point 0, 0. So if we do a little triangle here, we'd be going 2 across and 8 up. So the run will be 2 and the rise will be 8. So for the radius, m is equal to rise divided by run. The rise is equal to 8, the run is equal to 2, 8 divided by 2 is equal to 4. So that means the gradient of the radius is equal to 4. So for our tangent, to find the gradient, we'll do the negative reciprocal. So the reciprocal of 4, well, 4, if you take the reciprocal of 4, that's a quarter. And the gradient was positive, we're now going to make it negative. So it's going to be minus a quarter. So the negative reciprocal of 4 would be minus a quarter. And you can check that. Remember, if you multiply the two gradients together, we should get -1 because the two lines are perpendicular to each other. Because they made it 90 degrees, they're perpendicular. So, and if we do 4 times minus a quarter, that's equal to -1. Or we can just find the negative reciprocal, which is minus a quarter. Okay, so this is fantastic. We now know for our tangent, we know its gradient. So we've got y equals mx plus c. We've got y equal to, the gradient is minus a quarter x plus c. And we know it passes through the point 2, 8. That's a point on the tangent. So that's the x coordinate and y coordinate. And if we substitute those in, we can find c. So y, that's 8, is equal to minus a quarter of 2. So minus a quarter times 2, and then plus c. Minus a quarter times 2 would be minus a half. So we get that 8 is equal to minus a half. plus c, and then let's add a half to both sides. So that'll be, if we add a half to the left hand side, we'd have 8.5, and if we add a half to the right hand side, we'd just be left with c. So we now know what c is. C is equal to 8.5, or you may have it as 17 over 2 or 8.5. All of those are fine. So that means that the equation of the tangent will be y equals -1/4 x and then plus c, so plus 17 over 2 or 8.5. We may have written in decimal form y equals -0.25 x plus 8.5, and any of those are fine. And that's it. That's the equation of that tangent. Okay, let's look at our next question, question number 7. So question number 7, we've been given this circle, that's the circle x squared plus y squared equals 17. And we've got this tangent to the circle, and it touches the circle at P and carries on, and it crosses the x-axis at this point R. And we're told that P is the point that lies on the circle, and it's got an x coordinate of 1, so it's 1 something. And we're told that the tangent meets the circle at P and carries on, meets the x-axis at R, and we want to find the coordinates of the point R. Okay, so we want to find where this tangent crosses the x-axis. So we want to find the coordinates at this point. So if we know the equation of that tangent, then that'll be quite straightforward, because to find where a line crosses the x-axis, you know the height y is equal to 0. So let's find the equation of this tangent. But before we do that, we need to find the y coordinate of the point P. So what I'm going to do is I'm going to look at the equation of the circle. X squared plus y squared equals 17. So here we've got that x is equal to 1. So we get that 1 squared plus y squared is equal to 17. 1 squared, that's 1, plus y squared is equal to 17. And if we take 1 away from both sides, we get that y squared is equal to 16. So it means that y would be equal to 4 or -4 plus or minus 4. Now, if y was -4, it'd be down here somewhere. That'd be 1, -4 down there. This must be the point 1, 4. So we now know the coordinates of the point P. So that's fantastic. Now we know that point, we can now find the equation of that tangent. So let's do that. So to find the equation of the tangent, I'm going to find the gradient of the radius. And then once I find the gradient of the radius, then we can find the gradient of the tangent. And then we can find its equation. So let's find the gradient of OP. So for OP, m is equal to the rise divided by the run, rise divided by run. Well, to get from O to P, we would go across 1 and up 4. So across 1 and up 4. So the run will be 1 and the rise will be 4. So we're going to do rise divided by run. 4 divided by 1 is equal to 4. So that means the gradient of OP is equal to 4. M is equal to 4. So now we want to find the gradient of this tangent. And the gradient of the tangent, the gradient will be the negative reciprocal of that. So the negative reciprocal is positive, so that'll be negative, and the reciprocal of 4 will be 1/4. So that means that the gradient of the tangent is -1/4. And let's just check that. 4 times -1/4 is -1, so that works. Okay, so we know the gradient of the tangent is -1/4 because we know the two lines are perpendicular to each other, and so we've done the negative reciprocal of that gradient, and we find the gradient of the tangent. So now the tangent is in the form y equals mx plus c, so mx plus c, and the gradient of the tangent is -1/4, so y equals -1/4 x plus c. So we know it passes through the point P, and the point P has an x coordinate of 1 and a y coordinate of 4. So if we substitute those into the equation, we can find c, and then we'll know the equation of the tangent. And then once we know that, we can then find r, but we'll do that in a minute. Let's get the equation of the tangent. So x is equal to 1, y is equal to 4. So y, that's going to be 4, is equal to -1/4 times x, but x is 1, so -1/4 times 1 will just be -1/4, and then we've got our plus c. Now we want to get the c on its own, so let's get rid of this quarter, so let's add 1/4 to both sides. So we'd have 4 1/4, when we add 1/4 to 4, we get 4 1/4 is equal to c. So that's fantastic. We now know the equation of the tangent. If we substitute this into here, we're going to get that y is equal to -1/4 x plus 4 1/4. Or we could write this as 17 over 4 or 4.25. All of those would be fine. Okay, so we now know the equation of the tangent. We want to find r, where that tangent crosses the x-axis. So to find where this straight line crosses the x-axis, we know that its height is equal to 0. We know that y is equal to 0. So if we let this y equal 0, we're going to get that 0 is equal to -1/4 x plus 4 1/4, or 17 over 4. So this is fantastic. If we solve this equation, we can find out what x is. And then once we find out what x is, we can then find the coordinates of r. So let's do that. So to solve this equation, I'm actually going to add a quarter x to both sides to begin with. So add a quarter x and add a quarter x. So on the left-hand side, we'd have a quarter x, or quarter x. And on the right-hand side of the equation, we'll have 4 1/4. Okay, now we want to find out what x is. So we don't want this multiplied by a quarter. So let's divide by a quarter and divide by a quarter. And it's a calculator question, so we can just divide both sides by a quarter. A quarter x divided by a quarter would just be x. We're dividing by a quarter to get rid of the times by a quarter. And on the right hand side, we've got 4 1/4 divided by a quarter. It's a calculator question, so if you type that into your calculator, 4.25 divided by 0.25, or 4 1/4 divided by a quarter, or 17 quarters divided by a quarter, you're going to get that's equal to 17. So that means that x is equal to 17. So that means that it crosses the x-axis 17 across. Now, we've been asked to write down the coordinates of the point R. Well, that's just the x-coordinate. The coordinates will be 17, 0. So that's it. Let's write that down. The R is the point 17, 0. And that's it. So we'll find the coordinates of R, where that tangent crosses the x-axis. Okay, let's look at our next question. So question number 8 says the points D, which has got coordinates -12, -5, and E, the point with coordinates 12, 5, lie on the circle C. And DE is the diameter of C. So that's on one side of the circle, and that's on the other side of the circle. And part A says write down the coordinates of the centre C. So we want to write down the coordinates of the centre of the circle. So if DE is the diameter of the circle, the midpoint of DE will be the centre of the circle. So let's find the midpoint of DE. And to find the midpoint of two coordinates, we just add them together and half it. So we're going to do -12 plus 12, so -12 plus 12. And then divided by 2. And then we're also going to do -5 plus 5 divided by 2. So -5 plus 5 divided by 2. -12 plus 12 is 0. Divided by 2 is just 0. So that's 0. And then -5 plus 5 is 0. Divided by 2 is 0 as well. So if you add these two coordinates together and divide by 2, you'll get 0, 0. So that's the centre of the circle, 0, 0. Okay, and then part B. Part B says write down the length of the radius of C. So we want to write down the length of the radius of C. So we know the centre of the circle is the point 0, 0. And we know that one of the points on the circle is the point E, which is 12, 5. We could choose D, but I'm just going to choose E for the minute. So E is 12, 5. So that means that 0, 0 is the centre of the circle, and the point E, 12, 5, is on the circle. If we work out the length of that line, that's the distance from the centre of the circle to the point on the circle, so the radius of the circle. You could draw a whole sketch here, but I'm just going to do the centre of the circle, so the point 0, 0, and the point 12, 5, which is a point on the circle. And let's join those up. And then we're going to use Pythagoras' theorem to find the length of that line. So let's use Pythagoras' theorem to do that. So to get from 0, 0 to 12, 5, we're going to go across 12 and up 5. So if we use Pythagoras' theorem, we can find the length of that line. So we can find the length from the centre to the edge of the circle, which would be the radius of the circle. So we're going to do a squared plus b squared equals c squared. So 5 squared plus 12 squared equals r squared. And I've just labelled it r because that's the radius of the circle. 5 squared is 25. And 12 squared is 144. And when we add them together, we get r squared. 25 plus 144 is 169, and that equals r squared. And then if we square root, we're going to get that r is equal to the square root of 169, which is equal to 13. So that is equal to 13. So the radius of the circle is 13. Okay, and then part C. Part C says write down the equation of C. So we want to write down the equation of the circle. Now, the equation of the circle is good. The centre is the origin, so that means it's going to be x squared plus y squared equals r squared. So that would be the equation of a circle where the centre of the circle is the origin, and we know the centre of the circle is the origin from part A. So r is the radius, so that'll be x squared plus y squared equals 13 squared. And you could write that out as 169, but I would just leave it as x squared plus y squared equals 13 squared, and that's how I'd leave my answer, and that's it. Okay, and then part D. Part D says find the equation of the tangent of the circle C at the point D. So I'm just going to do a little sketch here. Okay, so I've just done a little sketch of a circle, and the point D, and D, if we go back up here, D is the point with coordinates -12, -5. So if we go down, -12, -5 will be there somewhere. So let's just do a tangent that touches there and carries on. Okay, so we've got a little sketch there, and we've got the point D here. That's the point -12, -5. And we've got the centre of the circle, which is O, the origin, the point 0, 0. And we want to find the equation of that tangent. So we want to find the equation of that tangent. So let's actually draw on the radius. So that's D and that's O, so that's the line DO, the radius of the circle. And if we can find the gradient of the radius, then we can find the gradient of the tangent, and then we can find the equation of the tangent. And just remember that the radius and the tangent are perpendicular to each other. They meet each other at 90 degrees. So let's find the gradient of the radius to begin with. So in terms of the gradient of the radius, to get from D to O, we would go across, and we would go across 12, and then we would go up 5. So we're going to go across 12 and up 5. So the gradient, m, is equal to the rise, which is 5, divided by the run, which is 12. So the gradient of that radius is equal to 5 over 12, or 5/12. That means the gradient of the tangent will be the negative reciprocal of that. So for the tangent, m would be equal to the negative reciprocal. So it's positive, so making it the negative reciprocal, we're going to change the sign, so we're going to make it negative. And then we're going to do the reciprocal of 5/12, so it should be 12/5. So that means that the gradient of the tangent is negative 12/5. So that's fantastic. We now know the gradient of the tangent, and we know a point on the tangent, the point D. We can now find its equation. Because it's a straight line, so its equation will be in the form y equals mx plus c. Y, well, that's the, if we have a look here at the point D, we've got our x coordinate and our y coordinate. And actually, let's just substitute in the gradient to begin with. We would have y equals negative 12/5 x plus c. So we know the equation of the tangent will be in this form. And if we substitute in the x coordinate and the y coordinate of a point on that line, the point D, we can then find c. So y, that is going to be negative 5, is equal to negative 12/5 multiplied by x, which is negative 12, and then plus c. Okay, so let's work this out. Negative 12/5 multiplied by negative 12, well, that'll be equal to 144/5. So negative 5 is equal to 144/5 plus c. And we want to get the c on its own, so we don't want this 144/5 here. So let's take away 144/5 from both sides of the equation. And it's a calculator question, so that's quite nice. So we just need to, on the left-hand side, work out what 5 minus 144/5 would be. So minus 5 minus 144/5 is equal to minus 169/5, and that's equal to c. So that's fantastic. That means the equation of the tangent would be y equals to minus 12/5 x, and then it'd be plus c, but c is equal to minus 169/5, and that's it. So that would be the equation of the tangent at that point D, and that's it. Now also, just to mention, you could write it in decimal form. You could write y equals minus 2.4x and then minus 33.8, and that would be fine as well, but I probably would leave it in this fractional form, and that's it. So that's the equation of the tangent to that circle at the point D. Okay, let's look at our next question, question number 9. So question number 9 says the point A, 4, negative 6, lies on the circle of equation x squared plus y squared equals 52. And we've been asked to find the coordinates of the point where the tangent to the circle A crosses the x-axis. And it's a calculated question, and we've not been given a sketch for this question, so I'm actually going to draw a sketch myself to begin with. So I'm going to start off by drawing the x-axis and the y-axis. So there's the x-axis and there's the y-axis. And then I'm going to draw a circle. Now, because the equation of the circle is x squared plus y squared, I know the center of the circle is the origin. So I'm going to draw a little circle where the center of the circle is the origin. And it says there's a point A, which is the point with coordinates 4, negative 6. So 4 across 6 down will be there somewhere. So that's the point A down here. And there's a tangent. So let's draw that tangent. So the tangent would look something like this. So the tangent would look something like that. And this is the point here, A, which is the point with coordinates 4, negative 6. And we've been asked to find the coordinates to the point where this tangent to the circle at A crosses the x-axis. So we want to find the coordinates to this point here. I'm just going to call that P. Okay, so to find where this tangent crosses the x-axis, I want to find the equation of the tangent. So to do that, let's find the gradient of the radius. So that's O and that's A. So if we were to make a little right angle triangle, we would go across 4 squares and then we would go down 6. So we'd have a run of 4 and a rise of negative 6. 4 across 6 down. So M, the gradient of the radius, would be equal to the rise divided by the run. The rise is equal to negative 6 and the run's 4, and if we do negative 6 divided by 4, that's negative 3 over 2. So that's the gradient of the radius of the circle. Now we can then find the gradient of the tangent, because that'll be the negative reciprocal, because these two lines are perpendicular to each other. So the gradient of the tangent will be the negative reciprocal of this. Well, if it's negative to begin with, so when we make it the negative reciprocal, that'll change the sign to become positive, and the reciprocal of 3 over 2 will be 2 over 3. So that means the gradient of the tangent is 2/3. Now that means that if we want to find its equation, because if we can find the equation of the tangent, we can find where it crosses the x-axis. So y is equal to mx plus c, it's a straight line. So we get that y is equal to m, the gradient of the tangent, which is 2/3 x plus c. Now we want to find the c, and to find the c we want to find a point that the tangent passes through. So that'd be the point 4, -6. So it's got an x coordinate of 4 and a y coordinate of -6. So let's substitute those into the equation of the tangent. So y, that's going to be -6, is equal to 2/3 times x, and x is 4, and then plus c. So now we just need to solve this to find c. So that's going to be -6 is equal to 2/3 times 4 would be 8/3 plus c. And to find out what c is, we want to get rid of this 8/3, so let's take away 8/3 and take away 8/3. And on our calculator, let's do -6 subtract 8/3. And when we do that, we get an answer of, we get that c is equal to -26/3. So that's fantastic. So we've now found the equation of that tangent. The equation of the tangent would be y is equal to 2/3 x, going up to here, 2/3 x minus 26/3. So that's the equation of the tangent. Now we want to find the coordinates of the point P where that tangent crosses the x-axis. And to find where a line crosses the x-axis, you know that the y is equal to 0. The height is equal to 0. So if we let y equal 0, we'll find where that line crosses the x-axis. So let's do that. So y will equal 0. So here, if we substitute 0 here, we're going to get the 0 is equal to 2/3 x subtract 26/3. So let's solve this equation. So let's add 26/3 to both sides. So we're going to get 26/3 is equal to 2/3 x. And then if we divide both sides by 2/3, and again it's a calculator question, so if we do 26/3 divided by 2/3, because we're dividing both sides of the equation by 2/3, we'll get that that's equal to 13. So x is equal to 13. And that's it. So that means that x is equal to 13. So the coordinates of this point will be 13, 0. Because it's 13 along and 0 up because it's obviously on the x-axis. So that's it. So that's the coordinates of the point where that tangent crosses the x-axis, 13, 0. Okay, let's look at our next question, question number 10. Okay, let's look at our next question, question number 10. So question number 10 says the point A, which is coordinates 10, 5, lies on the circle x squared plus y squared equals 125. And part A says work out the equation of the tangent to the circle at the point A. So we want to work out the equation of the tangent to this circle at this point A. So I'm going to do a little sketch here. So I'm just going to get a ruler and pencil. So I've got my ruler and pencil, and I'm going to draw the y-axis and the x-axis. And then I get my compass and pencil, or just something circular, because it's just a sketch, or maybe even freehand if you're good at doing freehand circles, or just even like a 5p or a 1p, not 20p. And so we've got a circle and we've got our x and our y axis there. And we know there's a tangent to the circle at the point A. A's got coordinates 10, 5, so it'll be 10 across, so it'll be over here somewhere, and 5 will be up there. Okay, so 10, 5 would be there, and we're just going to draw a tangent at that particular point. So the tangent would look something like this. Okay, so as we can see there, we've got our circle and we've got our tangent at the point A. I'm just going to label A, it's the point 10, 5. And we've been asked to work out the equation of this tangent. So what I'm going to do to begin with again is to work out the gradient of the radius. That'll then help us find the gradient of the tangent because they're perpendicular, and then we can find the equation of the tangent. So let's do that. So I'm just going to draw on the radius. So I'm going to get a ruler and pencil again, and I'm going to draw our radius there. And remember, that's perpendicular to the tangent. The radius and the tangent meet each other at 90 degrees, like so. So if we wanted to find the gradient of this line, we're going to do the gradient m is equal to rise over run. So rise over run. So the rise and run, so let's find them. So we would go across 10. So we'd go across 10, and then we would go up 5. So across 10 and up 5. So the rise is 5, and the run is 10. And 10 over 5, if we cancel it down, it would be a half. So the gradient of that radius is a half. Now we want to find the gradient of the tangent. So the gradient of the tangent will be the negative reciprocal of that. So the reciprocal of a half is 2, and we're going to change the sign from being positive to negative, so negative 2. And that makes sense, that's quite a steep line going downwards, and so because it's going downwards, it'll have a negative gradient, and a gradient of 2 makes sense. If that's a gradient of a half, then that's a bit steeper going down than this one going up. So yeah. Okay, so we've now got the gradient of that tangent is negative 2. Let's find the equation of the tangent. It's a straight line, so it'll be in the form y equals mx plus c. We know the gradient's negative 2, so it's y equals negative 2x plus c. And now we just need to substitute in a y coordinate and an x coordinate from a point on the line to find c. And we've got a point on the line, that's the point A. And we've got an x coordinate of 10 and a y coordinate of 5. So let's substitute those in. Y, that's going to be 5, is equal to minus 2x, so minus 2 times 10, that'll be minus 20, plus c. And then if we add 20 to both sides, we're going to get the c is equal to 25. So that means the equation of this tangent would be y equals minus 2x plus 25. Just putting the 25 back in here. So y equals minus 2x plus 25. So that's the equation of that tangent. Okay, let's look at our next part, part B. Okay, so part B says the tangent to the circle of the point B, so there's another point B, is parallel to the tangent to the circle of the point A. And we've been asked to work out the equation of the tangent to the circle of the point B. So let's go back up. So here we have got this tangent, and apparently there's another tangent that'll be parallel to this one. So if it's parallel, it'll have the same steepness. So here we've got a parallel line, and there's another tangent to the circle that's parallel, and as you can see, it would be over here somewhere, this point here. So if that's the point A, this must be the point B. So here we've got, if this is the point A, there's going to be a point B over here, that the tangent is parallel to the other tangent. So this tangent also has a gradient of negative 2, so minus 2. So let's consider what the coordinates of the point B would be. So here we've got the radius, so OA. So if O is the origin, we've got the line OA, that's the radius. But also BO would also be the radius as well. And then the whole thing would make the diameter. So if this radius goes across 10 and up 5, this radius must also go across 10 and up 5. So this goes across 10 and up 5. That means the point B must have coordinates negative 10, negative 5. Because if you're at negative 10 and you go across 10, you'll get to below the origin, and then up 5, you'll get to the origin. So that means that the point B is the point negative 10, negative 5. And so what I've done there is I just consider the radius OA, and I knew to get from O to A, we would go across 10 and up 5. And then this point here, because this must be the diameter, then we must go across 10 and up 5 to get to the origin from B. So that must mean that B is the point negative 10, negative 5. Okay, now that we know that the point B is the point negative 10, negative 5, we can work out the equation of this tangent, because we know the tangent is parallel, so it's got the same gradient, and we know a point it passes through. So let's do that. So we've got that y is equal to negative 2x plus c, because we know the gradient is negative 2. And now we're going to substitute in the x coordinate of negative 10 and the y coordinate of negative 5. So let's do that. Negative 5 is equal to negative 2 times negative 10 plus c. Negative 2 times negative 10 would be 20, so we're going to get minus 5 is equal to 20 plus c. And then if we take 20 away from both sides, we're going to get the c is equal to minus 25. And that's it. So that means if we put the minus 25 in for c, we're going to get the y is equal to minus 2x minus 25. And that's it. So that would be the equation of the tangent to the point B. And that's it. So let's write that down. Y equals minus 2x minus 25. And that's it. Okay, let's look at our next question, question number 11. So question number 11 says the line L is a tangent to the circle x squared plus y squared equals 90 at the point P. And the point P is the point 39. And we're told that the line L, that's the tangent to the circle, crosses the x-axis at the point Q. And we've been asked to work out the area of triangle OPQ. Okay, so with a question like this, I'm definitely going to draw a sketch. I just find it helps me visualize it. So let's start off by drawing the x-axis, and then the y-axis, and then a circle. So that's our circle, x squared plus y squared equals 90, and we've got our x and y axis. We're then told that the point P is the point 39, so 39 perhaps will be up there somewhere. Now we're going to draw a tangent. So that's our tangent to the circle, that's the line L, and it crosses the x-axis at the point Q. So that's Q, that's P, which is the point 39. And we've got the point O down here, which is the center of the circle. And we've been asked to find the area of the triangle OPQ. So we want to find the area of that triangle. So if we want to find the area of that triangle, it would be great to know what the coordinates of the point Q are, because we know what O is, 0, 0. We know what P is, 3, 9. And if we could work out the coordinates of the point Q, we could find the area of triangle OPQ. So let's do that. Now to find the coordinates of the point Q, we've done similar questions earlier on in this booklet where we've actually found where the tangent crosses the x-axis. So we need to find the equation of the line L and find where it crosses the x-axis by letting y equal 0. So let's find the equation of the tangent. So to find the equation of the tangent, I'm going to find the gradient of the radius, OP. And for that radius, what we'll do is we'll do rise divided by run. So m equals the rise divided by the run. So the rise, well, to get from the origin to P, we would go across 3 and up 9. So we're going across 3 and up 9. So we would do the rise, which is 9, divided by the run, which is 3, and 9 divided by 3 is 3. So the gradient of the radius is equal to 3, Now we know the gradient of the radius, we can find the gradient of the tangent because they're perpendicular to each other, they cross at 90 degrees. That's a really bad right angle sign there. They cross at 90 degrees. So to find the gradient of the tangent, we're going to do the negative reciprocal of 3. And the negative reciprocal of 3 would be m for the tangent, for the line L, would be the negative reciprocal of 3. Well, it's positive, so when we do the negative reciprocal, we'll change the sign, so we'll make it negative. And the reciprocal of 3 is a third. So that means the gradient of that tangent is minus a third. That's fantastic. So now remember, we're trying to find the equation of that tangent, and a straight line has the equation y equals mx plus c, So that's y equals m, which is the gradient, which is minus a third, x plus c. Now we want to find a point on that line, the tangent, so that we can substitute in. So we want to find a point, and we've got the point P. We've got the x coordinate of 3 and the y coordinate of 9. So let's substitute those in and find the value for c. So y, that's 9, is equal to minus a third times x. Well, that's minus a third, so minus a third of x, which is 3. And then we're going to add c. So a third of 3 would be 1. So minus a third of 3 would be minus 1. So we get that 9 is equal to minus 1 plus c. And then if we add 1 to both sides, we're going to get the 10 equals c. So that's fantastic. We now know the equation of the tangent. The equation of the tangent would be y equals minus a third x plus 10. So that's the equation of the tangent. Now we're trying to find the coordinates of this point Q. So we want to find where that tangent crosses the x-axis. And to find where it crosses the x-axis, we're going to let y equal 0. So let's let y equal 0. So we get 0 equals minus a third x plus 10. So we want to solve this, so let's add a third x to both sides. So we'd get a third x equals 10. We've just added a third x to get rid of this minus a third x on the right hand side. Now we want to get rid of this a third. Now we could do this in a couple of ways. We could divide both sides of the equation by a third, or we could times the whole equation by 3. And if we times the whole equation by 3, we'll get that x equals 30. So that means the coordinates of the point Q would be 30, 0. It crosses the x-axis at point 30, 0. So that's fantastic. We now know the coordinates of the point Q. We've got the coordinates of the point P, and we've got the origin, and we've been asked to find the area of the triangle OPQ. So I'm just going to draw another sketch. I'm just going to draw it over here. So I'm just going to draw another sketch over here of the triangle OPQ. So OPQ. Okay, and so we've got the point O, which is the point 0, 0, that's O. We've got P, which is the point 3, 9, and we've got Q, which is the point 30, 0. So in terms of that triangle, remember the area of the triangle is half the base times the height. Well, the base of the triangle is going to be 30. To go from here, the origin across the Q would go 30 across, so that's going to be 30. The height of the triangle, so that's from the base up to the highest point of the triangle. Well, this is the point 3, 9. It's 3 across and then 9 up. So that means the height of the triangle is 9. So if we want to find the area of this triangle, we're going to do half the base times the height. So we're going to do a half times the base, which is 30, times the height, which is 9. And 30 times 9 is 270, and half that would be 135. So the area of triangle OPQ is 135. Units squared, if you want to write that, unit squared, or just 135. You can just leave it as that, and that's it. Okay, let's look at our next question, question number 12. Okay, so question number 12, we've got this circle, which is x squared plus y squared equals 25. So it's a circle with radius 5, because remember it's the radius squared, so the square root of 25 is 5. And we've then told that it's got tangents at the point A and the point B. And as you can see, there's the two tangents, the tangent at A and the tangent at B. And the tangents meet at the point P, so they meet at this particular point here, P. And we're told that the coordinates of the point A are 0, 5, so 5 up. So yeah, the circle does have a radius of 5. And the point B has got the coordinates 3, negative 4, so 3, negative 4. And we've been asked to find the coordinates of the point P. So that's fantastic. So we want to find where these two tangents meet each other. We want to find the coordinates of this point P. And to find where two lines meet each other, I like to get them in the form y equals and y equals, and then put them equal to each other, and then solve that equation, and that'll tell us where they meet each other. So let's do that. So let's find the equation of this tangent, and let's find the equation of that tangent. And I'm just going to change color ink here to blues, just so it stands out a little bit more. Okay, so let's start off by finding the equation of this horizontal tangent, this tangent at the point A. So the point A is the point with coordinate 0, 5, so it's 0 across 5 up. And if we have a look at the tangent, all of those points will have a height of 5. So that means that's the line y equals 5. It's a horizontal line that passes through 5 on the y-axis. It's the line y equals 5. So that's the equation of that tangent. That was quite easy. Now we want to find the equation of the tangent at B. So to find the equation of the tangent of B, what we're going to do is we're going to find the gradient of the radius. We'll then do the negative reciprocal of that, because we know that the gradient of the radius and the gradient of the tangent, they're perpendicular to each other. So that means if you do the negative reciprocal of one gradient, you'll find the gradient of the other one. So we'll then find the gradient of that line, that tangent at B, and then we'll find the equation of the tangent at B. And once we know the equation of the tangent at B, we can then put it equal to the other tangent. As long as they're both y equals and y equals, you can put them equal to each other and solve it, and you'll be able to find the coordinates of the point P. Okay, so let's find the equation of this tangent at B. So let's find the gradient here. To get from O to B, we would go 3 across and then we would go 4 down. So the run is 3 and the rise is -4 because we went 4 down. So in terms of the gradient of this radius, M, is the rise divided by the run. So the rise is -4 and the run is 3. So that means the gradient of that line, that radius, would be -4/3. Okay, that's fantastic. Now, if we want to find the gradient of this perpendicular line, the tangent, what we're going to do is we're going to do the negative reciprocal of that. So because it's negative already, when we do the negative reciprocal, we'll change its sign, so we're going to make it positive. And the reciprocal of 4/3 would be 3/4. So that's fantastic. We now know the gradient of this tangent is 3/4. So we want to find its equation. So we're going to use the formula y equals mx plus c. Because it's a straight line, it's going to have an equation in that form. And we know the gradient is 3/4, so y equals 3/4 x plus c. And what we're going to do is we're going to substitute in the x coordinate and y coordinate of the point B, because that point lies on that line, that tangent. So if we substitute in 3 for x and -4 for y, we'll then find what c is. So y, that's -4, is equal to 3/4 times x, which is 3, and then plus c. Okay, so this is fantastic. We're getting closer to finding out what c is. Okay, now let's do 3 times 3/4, and 3 times 3/4 would be 9/4. It is a calculator question, so you can do it on the calculator if you wanted to, but I've just times the numerator by 3 to get 9/4, and then we've got plus c. And then I'm going to take away 9/4 from both sides to leave c on its own. So I'm going to do -4, take away 9/4. And it's a calculator question, so I'm going to do that on my calculator. -4 minus 9/4 is equal to -25/4, -25/4. So that's the value of c. And so if we just put that back in here, we've then found the equation of the tangent. The equation of the tangent is, this tangent here is y equals 3/4 x minus 25/4. Okay, so this is fantastic. We've now got the equation of the tangent at A, and we've got the equation of the tangent at B. And because they're both y equals and y equals, we've got y equals 5 and y equals 3/4 x minus 25/4. If we put them equal to each other, if we write 5 equals 3/4 x minus 25/4, and we solve this, we can find the x coordinate of this point P. So let's solve that and find that x coordinate. So I'm going to add 25/4 to both sides. So if we add 25/4 to the left hand side and add 25/4 to the right hand side, let's see what we get. So 5 plus 25/4 is equal to 45/4. And that's equal to, we're adding 25/4 to get rid of this -25/4, so we're left with 3/4 x. And now we don't want this times by 3/4, so let's divide both sides by 3/4. And if we do 45/4 divided by 3/4, we'll find out what that is on the left hand side, and that's equal to 15. So you get that 15 is equal to x, just dividing both sides by 3/4. So that's fantastic. We've now found the x coordinate of where those two lines meet each other. We know this point P has got an x coordinate of 15, and we found that because we know that it's got y equals and y equals. If we put them equal to each other and solve that, we can then find out the x coordinate of that point P. So we've done that. Now we want to find out what the y coordinate is. That's really simple. Because this is a horizontal line where all the heights are 5, it means it must be 5. It's going to be 15/5. You could, if you wanted to, do 3/4 times 15 and then minus 25/4, and you get that's equal to 5 as well. But it's much easier just to look at that line and say it's a horizontal line, all the heights are 5, so the y coordinate must be 5. So the coordinates of the point P are 15/5. So let's write that down, 15/5. Okay, let's have a look at our next question, question number 13. So question number 13 says a circle is drawn with center 0, 0, so the origin, and we're told that the point P, which has got coordinates 6, -4, lies on that circle. And a tangent to the circle at P crosses the y-axis at this point A. And we've been asked to work out the length of AP. So we want to find the length of AP. So if I wanted to find the length of AP, really what I want to do is I want to find the coordinates of the point A. And then once we find the coordinates of the point A, we can use Pythagoras' theorem to find the length of AP by turning it into a right angle triangle and using Pythagoras' theorem. So we want to find the coordinates of the point A. So to find the coordinates of the point A, we're going to want to find the equation of the tangent. Because if we can find the equation of the tangent, we can find the y-intercept, and then we'll know the coordinates of the point A, and then we can use Pythagoras' theorem and find the length of AP. Okay, so let's find the equation of this tangent. So to find the equation of the tangent, let's find the gradient of the radius, so the gradient of this radius here. So in terms of that radius, to find the gradient of that radius, to get from O to P, we would go 6 across and 4 down. So that means the run is 6 and the rise is -4. So M is equal to the rise divided by the run. The rise is -4 and the run is 6. So we're going to do -4 divided by 6, and that would be -2/3. So that means the gradient of this radius is -2/3. So if we want to find the gradient of the tangent, we're going to do the negative reciprocal of that. It's already negative, so we're going to change the sign to being positive, and the reciprocal of 2/3 would be 3/2. So that means the gradient of this tangent is 3/2. Okay, so that's fantastic. We've now got the gradient of the tangent. We want to find the equation of the tangent. So it's a straight line. So the equation of that tangent is going to be in the form y equals mx plus c. So it's going to be y equals m, the gradient, which is 3/2 x plus c. So we want to find an x coordinate and a y coordinate of a point that's on the line to substitute it in so that we can then find the value for c. So we've got the point P, and the point P, the x coordinate is 6 and the y coordinate is -4. So if we substitute those in, we can find the value for c. So y, that's -4, is equal to 3/2 multiplied by 6 and then plus c. That's a calculator question, and if you do 3/2 times 6, you get 9. So we're going to have -4 is equal to 9 plus c. And now let's take away 9 from both sides. So let's take away 9 and take away 9. -4 take away 9 will be -13, and on the right hand side we'll be left with c. So c is equal to -13. So that means the equation of the tangent is y equals 3/2 x minus 13. Now this is fantastic because this -13, that's the y-intercept for the tangent, so that's here. So that means the coordinates of the point A will be 0, -13. So that's fantastic. We now know the coordinates of the point A and the coordinates of the point P. We can then find the length of AP by turning it into a right angle triangle and using Pythagoras' theorem. So we've got a right angle triangle. To get from A to P, we would go across 6 and then we would go up 9. We would go across 6 because this is 0 across and this is 6 across. So we'll go across 6. And then in terms of how much we're going up by, we're going from -13 up to -4. And to get from -13 up to -4, we're going to go up 9. So we've now got our right angle triangle. We know the length of the two shorter sides. We can now use Pythagoras' theorem to find the length of AP. So let's do that. So I'm just going to change colour of ink here to blue. So we've got our two shorter sides. I'm going to label them A and B. And we've got our longest side, the hypotenuse of the right angle triangle, which is C. And Pythagoras' theorem is A squared plus B squared equals C squared. So A squared, that's going to be 6 squared, plus B squared, that's going to be 9 squared, and that's equal to C squared, so that's C squared or AP squared. 6 squared is 36, plus 9 squared is 81, and that's equal to C squared. We've got our calculator here. Actually, we could have done this in one go and just typed in 6 squared plus 9 squared, and if you do that, you get an answer of 117. Alternatively, you can add these and get 117 is equal to C squared. Now, this length obviously isn't 117, that's C squared, so we need to square root it. C is going to be the square root of 117, and if we square root 117, we get that's equal to 3 root 13, or as a decimal number, 10.81665, and so on. And I'm just going to round that. I'm going to round it to 3 decimal places. That'll be 10.817 to 3 decimal places. And that's it. That's the length of AP to 3 decimal places to 3dp. And that's it. Okay, let's look at our next question, question number 14. So question number 14, we've got this circle, and we're told a circle is drawn with centre O, so yeah, and a tangent to the circle passes through the points -5, 12 and 10, 2. So those points aren't actually points on the circle, they're just 2 points that are on that line. And then part A says find the equation of the tangent, so we want to find the equation of that tangent. So what we want to do is we want to find the equation of that line. So we know the coordinates of 2 points on the line, so we can actually find the equation of that line. So let's do that. Okay, so the equation of this line will be in the form y equals mx plus c. And we want to find m, the gradient of this line, and we want to find c, where it crosses the y-axis. So let's find the gradient to begin with. Let's find m. So we know these 2 points are on the line, so let's do a little right angle triangle. So we're going to go across and then we're going to go down. And to get from -5, 12 to 10, 2, we're going to go across 15 because we have to get from -5 to 10. So we're going to go across 15. And then we're going to go down from a height of 12 down to a height of 2. So we're then going to go down 10. So to get from this point to this point, we'll go across 15 and down 10. And so that's fantastic. We've found the run and the rise. So m, the gradient, is equal to the rise divided by the run. So the rise is equal to minus 10 and the run is equal to 15. And if we do minus 10 divided by 15, we get that's equal to minus 2/3. So that means the gradient of this line, the tangent, is equal to minus 2/3. So y equals minus 2/3 x plus c. Okay, so that's fantastic. We now know the equation of the tangent is in the form y equals minus 2/3 x plus c. Now I just want to mention that here we done rise divided by run. Now just to mention that you could have used the formula m equals y2 minus y1 over x2 minus x1, and that means that this would be x1 y1, this would be x2 y2, and so you would do 2 subtract 12 divided by 10 subtract minus 5, and then you'd substitute in those values. And if you were to do that, I'm just going to do it anyway just in case you like using that formula, and you get y2, which is 2, subtract y1, which is 12, divided by x2, which is 10, minus x1, which is minus 5. So we end up with 2 take away 12 is minus 10, and then 10 minus minus 5 is 15, and then whenever you cancel that down, you get that's equal to minus 2/3 as well. So that's it. So just to mention, if you like using that formula, that's totally fine as well. Okay, so I'm just going to get rid of that moment. Okay, so now we want to find out the value for c. So to find the value for c, we're going to choose a point that's on the line, so either this one or this one, and we're going to substitute in the x coordinate and the y coordinate. So I'm going to choose this one. I'm going to let the x coordinate be 10 and the y coordinate be 2. So we're going to get the 2 is equal to minus 2/3 times x, which is 10, and then we've got plus c. So then that would be equal to, we've got 2, and then that's equal to, minus 2/3 times 10, would that be minus 20/3, and then we've got plus c. Now we want to add 20/3 to both sides, so on my calculator, I'm going to do 2 plus 20/3, and we get that's equal to 26/3, and that's equal to c. So that means that c is equal to 26/3. So that means the equation of the tangent will be y equals minus 2/3 x plus 26/3. And that's it, that's the equation of the tangent. Okay, now let's have a look at part B. Part B, we've been asked to find the equation of the circle. So we want to find the equation of this circle. So this circle, the centre of the circle is the origin. We were told that in the question. So if you've got a circle where the centre is the origin, you know that the equation of the circle is going to be in the form of x squared plus y squared equals the radius squared. So in this question, what we know is, we know the first part, we know the equation of the circle will be in the form of x squared plus y squared, but we need to find out what the radius of the circle is, because if we can find the radius of the circle, then we can find that right side of the equation. We'll know it's equal to the radius squared. So we need to find the radius of this circle. And to find the radius of the circle, what I'm going to do is I'm going to find the distance between the point O, the origin, and this point here, the point where the tangent meets the circle. And if we can find the length of that line, then we can find out the radius of the circle. So we need to find the coordinates of this particular point here. So let's do that. So what we're going to do here is, well, we know the equation of the tangent, and we know the tangent and the radius are perpendicular to each other. So I'm just going to draw the radius in here. So the radius is this line here, and we know that those two lines are perpendicular to each other. Thinking back to circle theorems, the radius and the tangent are perpendicular to each other, and I think I've mentioned that in every question so far that we've gone through in this video. So here we know that the radius and the tangent are perpendicular to each other. So we know the equation of the tangent is y equals minus 1/3 x plus 26/3. Now what I'm going to do is I'm going to find the equation of this radius, because if we can find the equation of the radius, we can then put it equal to the equation of the tangent and find where they meet. And then if we know the coordinates of this particular point here, then we can find the equation of the circle. So let's do that, and I've just changed colour of ink here to blue. So what I'm going to start off by doing is finding the gradient of the radius. The gradient of the tangent is minus 2/3. That's the gradient of the tangent. The gradient of the radius will be the negative reciprocal of that. So the negative reciprocal will change the sign to being positive, and the reciprocal of 2/3 is 3/2, so 3/2. So that means the gradient of the radius is 3/2. So if we wanted to write down the equation of the radius, that would be y equals mx plus c. So that'd be y equals 3/2, which is the gradient, x. And then in terms of our plus c, well, we know that c is the y-intercept. And because this is the radius and the centre of the circle is the origin, it's going to cross the y-axis at 0. So we could write plus 0, but I would actually just leave it at that. I would just say the equation of the radius would be y equals 3/2 x. So this is fantastic. We now know the equation of the tangent, we know the equation of the radius. If we put them equal to each other, because they're both y equals and y equals, if we put them equal to each other, we can solve that equation and find the x coordinate of this particular point here. I'll just call it p. We can find the x coordinate of p. So let's do that. Let's put the two equations equal to each other, because we have y equals minus 2/3 x plus 26 thirds, and we've got y equals 3/2 x. If we want to find where they meet each other, because it's just y equals and y equals, we put them equal to each other, and we would get minus 2/3 x plus 26 thirds is equal to 3/2 x. Okay, so we now want to bring all the letters to one side. So I'm going to bring all the letters to the right-hand side and leave all the numbers on the left-hand side here. So I want to get rid of this minus 2/3 x. And to get rid of 2/3 x, I'm going to add 2/3 x to both sides of the equation. So the left-hand side will be 26 over 3. And the right-hand side, we've got 3/2 x. We're adding 2/2 x. So if we just do on our calculator, 3/2 plus 2/3, that's equal to 13/6 x. So we've now got 26 thirds equals 13/6 x. We want the x on its own, so we want to get rid of this multiplied by 13/6. So let's divide both sides of the equation by 13/6. So let's divide the left-hand side of the equation by 13/6, and let's divide the right-hand side of the equation by 13/6. And I'm just going to do this on the calculator. 26 thirds divided by 13/6, and that's equal to 4. So that's what we get on the left-hand side. And on the right-hand side, we're dividing by 13/6 to get rid of the timesing by 13/6, so we'll just be left with x. So we now know the x coordinate of P, that point that we call P, where the tangent to the circle is, that the x coordinate is 4. So let's go up. We know that the x coordinate of this point P is 4. Let's now find the y coordinate. So to find the y coordinate, we can either substitute 4 into the equation of the tangent. So we can substitute 4 into here and do minus 2/3 times 4 plus 26 over 3. And you can do that if you want to. Alternatively, we could substitute 4 into the equation of the radius, and we can do that. And we can do 4 times 3 over 2. So either one of those would be totally fine. I'm just going to check we get the same both ways. So 3 over 2 times 4 is equal to 6. So that'd be the 0.46. Alternatively, if we do minus 2/3 multiplied by 4 plus 26 thirds, we get that's equal to 6 as well. So we get 4/6. So that means the coordinates of the point P are 4/6. So this is fantastic because we were asked to find the equation of the circle, and if we want to find the equation of the circle, the center is the origin, so we know it's going to be in the form x squared plus y squared equals the radius squared. So we know the left hand side, that's quite straightforward, x squared plus y squared, but we want to find out what the radius is. So let's find the radius of the circle, and to find the radius of the circle we need to find the distance between O and the point P, which is 4/6. So I'm just going to do a little sketch here. So we've got the point O, which is the point 0, 0. We've got the point P, which is the point 4, 6. And we want to find the radius of the circle. So let's consider our little right angle triangle. And to get from 0, 0 to 4, 6, we would go across 4 and then up 6. So let's use Pythagoras' theorem to find out the length of the radius. So let's label our sides A and B. So we've got the A squared plus B squared equals C squared, the hypotenuse squared. 4 squared plus 6 squared is equal to C squared. And if we do 4 squared plus 6 squared on our calculator, we get that's equal to 52. So we get the 52 is equal to C squared. So that's that length squared. And that means then if we square root both sides, we're going to get the C is equal to root 52. So that means that the radius of the circle is the square root of 52. So that means, and if we go back up there, that means that this length here is root 52, the radius of the circle. Okay, so if we go back down, we now know that the radius is equal to the square root of 52. So we're going to get the square root of 52 squared. And if we square the square root of 52, we just get 52. So that means the equation of the circle is x squared plus y squared equals 52. And that's it. So I'm just going to do a quick recap of this question. So we had the tangent that touched the circle, and we had 2 points on the tangent. We were asked to find the equation of the tangent, so we worked out the gradient of the line that joined those 2 points, and we found that to be minus 2/3. We then knew that the equation of the tangent would be in the form y equals mx plus c. So we put in the minus 2/3 there. And then we put in one of the points that was on the line. We could put either one of those in and you get c is equal to 26 over 3. So we found the equation of the tangent to be minus 2/3 x plus 26 over 3. Next, we were then asked to find the equation of the circle. To find the equation of the circle, I decided that I would find the coordinates of the point P, because we know that the circle is going to be in the form of x squared plus y squared equals the radius squared, so we need to find out what the radius of the circle is. And if we find the radius of the circle, then we can put it into x squared plus y squared equals the radius squared. So to find the length of the radius, we would be really useful if we knew what the coordinates of the point P were. So what I done was I said, well, if the equation of the tangent is y equals minus 2/3 x plus 26 over 3, the equation of the radius would be, it's perpendicular to it, so it'd be y equals 3 over 2x. And it crosses the y-axis at the origin, so it'd just be y equals 3 over 2x, and that's it. Then to get the coordinates of the point P, we put those two equal to each other and solve that equation. And when we do that, we get x is equal to 4. So that means the x coordinate of the point P is equal to 4. We then put that 4 into one of those two equations, either the equation of the tangent or the equation of the radius, to find the y coordinate, which would be 6. So we find the coordinates of the point P to be 4, 6. Then once we know the coordinates of the point P, we can then work out the distance between those 2 points. You can use Pythagoras' theorem to find the distance between 2 points. So we've got the origin and the point P, which is a point on the circle. So when we use Pythagoras' theorem, we find that the length of the radius is equal to the square root of 52. So that means the length of OP is root 52. Then finally, we know the equation of the circle is in the form of x squared plus y squared equals the radius squared. The radius is the square root of 52, so when we square that, we get 52. So that means the equation of the circle is x squared plus y squared equals 52. And that's it. Okay, let's have a look at our next question, question number 15. So question number 15 says a circle is drawn with centre 8, -5. And the circle passes through the point P, which has got coordinates 12, 2. And we've been asked to find the equation of the tangent to the circle at P. So this time the circle doesn't have a centre as the origin. This time the centre of the circle is the point 8, -5. So let's draw a little sketch here. So I'm going to draw the x and y axis. Okay, so I've just drawn the x-axis and the y-axis, and we know the centre of the circle is 8, -5, so 8, -5 would be down here somewhere, so the centre of the circle will be here somewhere. Okay, so I've just drawn a circle with centre 8, -5, 8 across, 5 down. Now, in terms of this circle, I may not have drawn it in the right position, so for instance here, I've got it crossing the x-axis twice, and I haven't got it crossing the y-axis at all. It would be quite useful whenever I'm doing a sketch like this to do it in pencil, so that as I read more information, I might sometimes adjust or change my sketch slightly to match what we've been given. And then we're told the circle passes through the point P, which has got coordinates 12, 2. So if this is 8 across, 12 across will be over here somewhere, and 2 up here somewhere, so perhaps there. So that's the point with coordinates 12, 2. And it's above the x-axis, so my sketch is quite good there in terms of the fact that my circle went above the x-axis. If I had originally drawn a circle which was below the x-axis, then I'd probably rub it out at this point, move it up a bit, and then have a sketch to look something like this, because this point needs to be above the x-axis. And then we're told to find the equation of the tangent to the circle at P. So let's draw a tangent at that point P. So this is the point P, let's draw a tangent at that point. Okay, so we've drawn a tangent to the circle at the point P. Now we want to find the equation of this tangent. So we've done this quite a lot already in this video. To find the equation of the tangent, it'd be quite useful if we can find the gradient of the radius. So we can find the gradient of the radius here by doing rise divided by run. Then once we find the gradient of the radius, then we can find the gradient of the tangent. And then once we know the gradient of the tangent, then we can find the equation of the tangent. So let's do that. To get from the centre of the circle to P, we would go 4 across and 7 up. Because to get from 8 to 12, we're going to go 4 across. And then to go from a height of -5 up to 2, we're going up 7. So we're going 4 across and 7 up. So that means the gradient of the radius, m, will be found by doing the rise divided by the run. The rise is equal to 7, the run is equal to 4, so that means the gradient of the radius is 7 over 4, or 7/4. Now we want to find the gradient of the tangent. So the gradient of the tangent, remember they're perpendicular to each other, so we're going to do the negative reciprocal of that. So it's positive, so we're going to make it negative, we're changing the sign, and we're going to do the reciprocal of 7 over 4, which would be 4 over 7. So that means the gradient of this tangent is -4/7. Now we're trying to find the equation of the tangent, so it's going to be in the form y equals mx plus c. We know the gradient of the tangent is -4/7, so y equals -4/7 x plus c. So we now just need to find c, the y-intercept. Now we know it passes through the point P, which has got coordinates 12, 2. So the x-coordinate is 12 and the y-coordinate is 2. So if we substitute those in, we can find out what c is. So let's do that. So if we substitute those in, so we've got here y, which is 2. So I'm just going to go over here, 2 is equal to 4/7 times x, so that's 4/7 times 12. And it's a calculator question. I'm going to do it on the calculator. -4/7 times 12 is equal to -48/7, and then we've got plus c. Now we want to get the c here, so let's add 48/7 to both sides. And when we do that, we get the c is equal to 62/7. So we find c, we find that it's equal to 62/7. So that means we can substitute that into the equation of the tangent to get the y is equal to -4/7 x plus 62/7. And that's it, we've found the equation of that tangent. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on the equation of a tangent to a circle. If you need any extra help on this topic, if you go to Corbettmaths and go to the videos and worksheets section and scroll down to video number 372, there's a dedicated video tutorial there on finding the equation of a tangent to a circle. Alternatively, you could scan this QR code. But in this video, we're focused on the video solutions to the practice questions, and I really hope you found them useful. And if you have found them useful, please like this video and please subscribe to the YouTube channel. Thank you. Cheers. Bye.